Hi friends, welcome to Civil Engineering. My name is Elvis. I hope you are all fine. Today we'll be looking on how to find the depth of a footing in construction. We'll be looking on how to find the depth of a foundation, of a footing. So guys, here we go. And before we begin guys, if this is your first time in this channel, do not forget to like this video, you subscribe and you hit on the notification bell to always have the latest updates guys. So let's begin. If we are asked to find a depth of a footing in construction, first of all guys, to find the depth of a footing of G plus 1 floor, let me say G plus 1 floor, G plus 1, which is a single floor. The depth of a foundation, from my own research guys, the depth must be at least from 1 meter to 1 meter 20, and the depth of a footing must be at least 1 meter to 120, which means that if the depth is 1 meter 20, then the width of the foundation of the footing must be at least 1 meter. If the depth is 120, the width should be 1 meter. So this is for G plus 1. 1 meter to 1 meter 20 for depth. Then guys, there is also another way to find the depth of a foundation of a footing using a formula. Yeah, using a formula, Rankins formula. This is the formula. Rankins formula. Which is, the formula is this, which is D, it is equal to P over W in bracket 1 minus sine theta divided by 1 plus sine theta all square. This is the formula to find the depth of a foundation. But guys, this is our mesh. We consider this mesh, it is down on our footing pit, and at the center here you can see this is a column, which is a pillar. This is a pillar which is directly at the center. If this pillar, it is somewhere around this point, it is not at the center and it cannot carry this load, because this load, it is coming directly at the center, and if it falls directly at the center, guys, you can see if it falls directly at the center, you have to share, the load have to be shared on this mesh. So if this pillar, if this column is around this area which is not at the center, it can easily have problem. It can easily sink, because when the load will come, it will share but towards this direction most, and if you share towards this direction most, it will this will easily sink. So you guys are already seeing it. So this is the difference. If it is around this area, that it is not at the center, it can easily sink. So that's why you see it is directly at the center. And your stirrups, these are stirrups guys, these are stirrups. You will space your stirrups at least 15 centimeters. This is it, 15. This, the distance between your stirrups, at least 15 centimeters. Also your mesh, the distance at least 15 centimeters guys. This is also the same 15 centimeters. center to center. This is for center to center of your mesh, at least 15 centimeters. And this is overlapping. Here you can see this is overlap. This is overlap. It should be at least 30 centimeters. This is overlap to join the iron. So this overlap should be at least 30 centimeters, and your stirrups have to be close, at least even 10 centimeters in this portion of overlapping. Sure you are seeing it. You're overlapping this portion should be at least 10 centimeters closely. Your stirrups at least 10 centimeters close to each other, center to center, towards the portion of overlapping. Then this formula to use to look for the depth of a foundation, they can give you because this D is stand for D. This is the D. The depth. This is D. The depth of foundation. D, it is depth of foundation. Then this P, this is load of, this is equal to structural load. Structural load. Then this 1 minus sine theta, ground, it is not at the perfect level, so ground can be like this. You can see ground can be like this. So this angle, it is called the angle of repose. This angle, it is this angle. And the angle is always 15 to 20 or 25 to 30. This angle, but when they want to give you, they must give this angle for you to use. So this is the formula. So they can give you the structural load to be, 2,000 kilogram per meter square. Then they will give you, because this is density, this one is density of soil. W is equal to density of soil. Sorry guys. W is equal to density of soil. O, this is density of soil. O internal friction. Internal friction. Yeah, so they can give you the structural load to be 2,000 kilogram per meter square. Then they will give you the density of soil to be maybe 1,500 kilogram per meters cube. You can see, to use this formula, D will be equal to 2,000 over 1,500 in bracket 1 minus sine. This, maybe they can give you this angle to be maybe 20, to be maybe 15. We don't know what they will give. Divided by 1 plus sine 15 all square. So if you manipulate this with your computer, with your calculator, you see that the answer will be given. And guys, do not forget, this is your hooks. This is your stirrups, and this is the hook. It should be at this angle. This angle of your hook must be 135, guys. Must be 135, and this one that is just 190. You can easily open when it is being loaded, and when it is being loaded, and when there is load, This can easily open when there is bending moment. It can easily open, or when there is shear force, this can easily open at the angle of 190, at the angle of 90 degrees. But this angle of 135, you see, it is really bent well, you see. But this one, it is 190. It can easily open when there is bending moment or shear force that wants to occur. So you see, this is it, guys. Please, if you like this video, guys, do not forget to subscribe, you like, and you hit on this bell, guys, to always have the latest notification. See you in my next video, and thanks for watching.